So in this case, we are simply going to have a continuation from the previous classes that we had. So without wasting time, guys, remember we managed to work on the power factor correction that was using the capacitor bank, all right? Working with the capacitor banks. And we saw that the power triangle is going to be like this at the end. Remember, we are dealing with a lagging power factor. And I talked about this, guys, the power triangle that you're going to have, the calculations that you are going to also have, and also we did the calculations. So like I said, for you not to miss any of other classes that you're going to have, make sure that you're part of the membership so that you won't miss any of the examples and question papers that we're going to be working with, preparing for the exams that are ahead of time. So in our case now, we have the synchronous condenser. This is the major part that we are having, or the synchronous motors in the power factor correction. So what is the use, or what is it that we are having? So a synchronous condenser is simply a DC excited synchronous motor with no mechanical load. So that is the major part that we are having there. So let us just have this definition. A synchronous, that is a synchronous condenser. This is the major part. So a synchronous condenser is a DC excited, all right? It is a DC excited synchronous motor. That's a DC excited synchronous motor with no mechanical load, with no mechanical load. So that is the major part that we are going to have, with no mechanical load. So what is it that we actually have? Or what is that it means? It simply means it operates with nothing connected to its shaft. That is the major part there. It operates. It operates with nothing. All right, with nothing connected to its shaft. That is the major part, to its shaft. That is, we are operating with no mechanical load. So, guys, all these, do not even worry, guys, to say, okay, it's going to be like this. Okay. What is the major part? The power triangle at the end of the day is what we want to see. The power triangle before and after installing that synchronous motor or the synchronous condenser. So how is it going to look like? That is the major part, all right? So the power triangle before and after. So I'm going to explain that, and we're going to look into questions thereafter, which is the major part, before and after installing a synchronous motor. A synchronous mode. That is the major part that you're going to have. Just like what we had in our previous class, that we're working with the capacitor bank. We had this, all right? So in our case, guys, the synchronous motor will be working at a leading power factor, all right? The synchronous motor will be working at a leading power factor. So the synchronous or let me write this one because it is important. We are going to refer to that one. So a synchronous motor will be working, all right, will be working at a leading power factor. At a leading power factor. So that is the part that we are going to have. So on our power triangle, this is what we are going to have at the end, because it is working with a leading power factor. So you are going to notice that we are going to have the basic, remember before this part here that we had when we are having our normal operation, this part. We were having the power, all right, our apparent power, this S1, which is the load kVA, and the resultant. So this part is going to remain, that is of the power, the true power, and the load, this one, it is going to remain as it was before. So it is going to be like this because that is the original part. When when the synchronous motor is not yet connected before the power factor correction. So before the power factor correction, we were going to notice something like this. All right, let me just, I'm just going to extend it later on. Do not worry. I'm just going to extend it later on, but it was supposed to be like this. All right, we were supposed to have something like this and another one like this. All right. So this part that we are having is of the original, when everything is original. All right. Nothing, no, there's no effect there. Those are the original conditions that you are given. So taking this from the origin here at the point O, I'm going to refer that as the origin. Remember, guys, I told you that whenever you're dealing with original values, you use what? You use 1. We're just going to denote with 1. So even this angle, the whole of this angle that we're going to have here is supposed to be what? Phi 1 like this. And this is P1, which is our load. So this is the kilowatt load that you're given, the power. All right. Then here we're going to talk of S1. Remember, this is the load, kilovolt ampere that we are having here. That's our load, which is our load kVA. All right, that's our S1. So we were going to have the resultant here. If we were dealing with that capacitor being, we're going to have a resultant here like this. But this time we are not connecting capacitor being, so we're not going to have our resultant ending like this. No, it is not going to be like that because we connected what? A synchronous motor, which is working at a leading power factor. So the motor is going to be, we are going to start to see the operation of the motor here. We're going to start from this point. Okay, let's have, remember, I want to see the leading part. So we are supposed to have this horizontal line. Remember, whenever we're talking about this one, it is a lagging. Normally, we'll be having our load at a what? At a lagging power factor. All right. So this part that we are seeing here is of the lagging power factor. Remember, this one is of the lagging power factor, guys. We talked about this before. This side in this region, we are going to be concentrating with what? Negative angles. That is for a lagging power factor, just like what we had here. This is for what? A lagging power factor. But the synchronous motor that we are connecting, it is going to be working at a leading power factor. So this is it. So we are going to have the horizontal presentation, just like the each and every part, guys. We refer from what? Horizontal line as our reference. So this was going to be the reference for the what? For the motor. We are now considering what? For the motor now. Just need a horizontal line, something like this. So it was going to be a reference like this. On this reference, that reference that we are talking about, the point, the distance here that we are talking about here, it is representing what lies on the reference, guys, is what? Is the true power. So even on our synchronous motor here, what lies on the horizontal is what? The true power. So meaning to say, here on this horizontal, we are having the true power for the motor. And whenever we're talking about the motor, it is the input that we're talking about, the input power. That is the true power that we are having. Or we're simply talking about the kilowatt, just like the load kilowatt, but this one is for the motor. So let's just gonna put M to represent it's what? For the motor, the synchronous motor that we connected, which is working at a leading power factor. So this one, remember, it was like this. This is your reference. All right, this is our reference. And we are saying we are working with a lagging power factor. So it was going to be like this, lagging. All right, we are going this side. But this one is working with a leading power factor. This is our reference here. So leading, it is supposed to be on top. So this is the condition that we are going to have on a leading power factor. So the angle is going to be on top for this one. Just like our S, this one, this S is going to be like this. We are going to have it this way, going this direction because of what? It is on a leading here. That is the major part that we are having. The angle from the reference, it's leading. There, it's lagging. We are going down. So this one is of the motor. All right. So meaning to say that is the synchronous. All this part here is of the synchronous motor. That is the case, guys. So this is the angle that we have since it is working with a leading. So this here, this part, what does it represent? Just like this one, our kVA. So this is the kVA of the motor. So we're just going to write as SM, apparent power, which is the kVA of what? Of the motor. So that is the case. So analyze it, guys, mathematically, we can even see this distance here from this point to here. It is same that we can take here to this point. So we can even extend. So it was now going to be an extended line here that we are having like this. Not to say it is 1 point or something. No, there are two things that are separate there. All right. Remember here, sorry, I'm just gonna need to remove something here. So it's not like there are two things there. It's not like it's one thing. I mean, there are two separate things that we are having. They are two separate. The first part, it is of what? The load. This part here, this part here, this one, and this one. It is representing the same thing. It is of the motor. So we are talking about the PM of what? The motor, the power of the motor there, the kilowatt of the motor. This is the one. Same power that we are seeing here. According to the presentation, guys, this is the same line here. Same line. That's why we are saying it's the same thing. So as we can see, these are two different points. So let us say this is point O, which is our origin. This is A. From O to A, that is of the original that we are given from the Lord. Then we call this point B. From A to B, it is the same as this distance. It is the power of the motor. It is the true power, but of the motor. This one, it is the true power, but of what? Of the Lord. So they are two different things. If you understand that way, guys, we are done. If you just understand this part, guys, we are done. So this is it. We can just connect here. It's just going to be vertical. And also here, we're going to have another vertical presentation like that. All right. So this is how we are going to have our diagram at the end. Okay, let's just try to reduce this one a little bit. And also this one. Just hope it is not going to affect our presentation, guys. Something like this. All right. So it was going to be something like this. So here, this line mathematically, guys, here we can see this line, this vertical line is the same as this vertical line. So let's say these are points O, A, B, C. This is D, because this one is not important. So let's just call it E there. All right. Like this one. So you can see that AD is equal to what? Is equal to BE. That is what we can notice there. A to D is the same as from B to what? As from B to E. The same thing that we can see here from A to B, this one. AB on its own, AB is equal to what? Is equal to DE. It is important that you note that from your diagram, from A to B, this one. So this is the concept. So where is going to be the resultant? This boss, we are saying here it is the part of our synchronous motor, which we connected for what? Power factor correction. So what is going to happen? This was our load kVA without this synchronous motor connected. Now the synchronous motor is connected. We are going to notice the resultant, just like the previous case, our resultant here of what? This one, of the kVA. After we have connected our synchronous motor, this time our resultant is going to be like this. It is going to be taken from the origin to the point C. That is going to represent our resultant. Just like that. So that is how our triangle, our power triangle is going to look like in a condition that we have installed what? A synchronous motor. And it is at when it is connected, it is at any power factor, not a unity power factor, because we are going to notice another part when it is on a unity power factor. I'm just going to draw the diagram later on, but this is a normal presentation that you're going to have. All right. So this part here is our resultant. Remember, I said this is our resultant what? KVA, which is our S2, just like S1. So that's our S2, which always operates at a certain angle. So definitely it is going to be operating at a certain angle, which is our phi 2. That's the angle that you'll be having there. So that is the condition of our values. So 1 is of the original values. What about 2? The resultant. All right. So whenever we see 2, it is of what? The resultant. So for resultant, you are going to denote with what? With 2. What about for the synchronous motor? For the motor, which is our synchronous motor, in that case, our synchronous motor, we are going to just use M to represent where the motor is, like the input power, just going to write PM, the apparent power, we're just going to use SM so that we understand each other. All right. We understand from the load, this line here from A to D, because it is from the load. This is our KVA reactive, this one, just like AC. You see from our diagram when we're dealing with capacitor banks, A from A to C, that was our Q1 from A to C. It is the same thing that we are having here from A to D. It represents what? It represents the load kilovolt ampere reactive. So it is the same thing as what we have from B to what? To C. So meaning to say, as long you have got your AD, which is your load kilovolt ampere reactive, you are having BE at the same time. All right. It is important for you to note that. But on this side here of BC and CE, from C to E, this one, it is the part of the motor, this one. From C to E, this one, it is the part of the motor. So meaning to say, C to E, it represents the kilovolt ampere reactive of what? Of the motor. We are dealing with what? It's the synchronous motor. Like I said, this triangle is of what? The motor. So that is it. It will be at 90 degrees here. This one, it will be at 90 degrees here. This one at 90 degrees like that. So that is the major part of our diagram. With this, you can answer any question depending with what you're given. They will give you information. I don't know what are they going to ask you there. For your power factor correction, are they going to ask anything about this? Whatever they are going to ask after that, you're supposed to use trigonometry to solve problems. So that is the part. So to solve problems, use what? Trigonometry. Use trig concept. The trigonometric concept to solve problems. That is the major part. That is you're going to apply. So guys, I explained everything. Before we connected the synchronous motor, and after, when the synchronous motor is now connected, that our resultant is going to be this one after everything has been connected. So you are supposed to understand this and go back to the basics of everything that we talked about. So I think, guys, that is it. With this, everything is direct. Wherever we see the M, it is representing what? The motor. So guys, for the issue of writing this, I want you to write all those part, but I hope just you understand what I just wrote here. So this is how it is going to be like. I want you to revise as much questions as you can. So when you are working with a unit power factor, how it is going to look like, because some of the questions they might be given where it is working with what? a unity power factor. So a synchronous motor. All right, let us just finish this part. A synchronous motor operating at a unity power factor. At a unit power factor. So this one is important on its own unity power factor at a unity. Remember, power factor. So it means the power factor of the synchronous motor is equal to 1. That is the case here of the synchronous motor here. When it is equal to 1, it means we are not going to have this here, this part. There is no angle that we are going to have there because it is directly equal to 1. It is at 0. This SM will be equal to what? Will be equal to PM. When SM is equal to PM, you know that you are operating at what? At a unity power factor. That is the condition when these two are equally the same. So it means SM here, this one, won't be there. It will be where PM is. It lies where PM is. That is the only part that is we are going to see there. So meaning to say, just like the previous case, guys, that we had, our original diagram of the load is going to be like this, as we saw when we are having the load, the power, and also the load kVA like this. And also we managed to join this part. Like I said, we can even join from this point to this point. All right, something like this. All right, so here this is what we are going to have. Like I said, guys, this is of what? Of the load from the original concept that we are having. So it's from from point O to point A. Then the synchronous motor is now connected, but it is working at a unit power factor. But the moment that it is connected, we are going to have this horizontal presentation just like previously. So we are not going to have the angle now that is going up like this, like what we saw to say this. Here, this one, our SM is equal to PM. So it's going to go down like this. It goes down, it goes down, it goes down until it lies direct where this PM is. Like. So it will be on the same line like this. So what does it mean? There's nothing. Because it will be on the same line, you see. So that is the consideration, guys, just like that. So guys, do not even worry. So this one, remember we said these two are exactly the same from here and here. So that is how it is going to be like. And here we can just even join these 2 points, all right, just to show that there are 2 points there. So that is how it is going to be like OA, B, C and D. All right, let's just write like this. So this is what we have. We are no longer having this angle here because it is at a unity power factor. So therefore, what is going to be the resultant? Because the case is, guys, the synchronous motor has been connected. So power factor correction has to play a role. So we have, or we must have the resultant, this one, connected to C. So it will go to C this time, our resultant. That is how it is going to be like at the end. So with this, guys, we are done. So this is our resultant kilovolt ampere. And here, this was from the load. So this is our load kVA, this one, which is our S1. All right. And also as for the angles, the whole of this angle, the whole of that angle is our phi 1. And after the synchronous motor was being connected, we are going to have this angle now. All right. So that is it. From point O to point A, that is the input power, the kilowatt that we are having of the load. And from point A to point B, which is the same as from point D to C, that is of the motor, this one. So the power there is of the motor. That's the PM, the input of the motor. just like that. From A to D, this part here from A to D, that's our load kilovolt ampere reactive from A to D, which is the same as from B to C. Remember, that's our load kilovolt ampere reactive, right? AB is of what? The motor, this one. The input of the motor. We are dealing with what? The input. So that is the condition. So a unity power factor, like I explained, it occurred because of this SM being equal to what? To PM. That is the consideration. So it is a condition where SM is equal to PM. Remember, PM is the power of the motor, which represents the kilowatt of the motor. What about SM? That is our apparent power, which is the kilovolt ampere of the motor. So it means the kilowatt and the kilovolt ampere of the synchronous motor will be exactly the same. So the angle that is affecting there of the motor will be equal to what? 0 degrees, so that our power factor for the motor will be equal to what? Will be equal to 1. That is those are the conditions that you need to understand. So like I said, for you to solve anything, operate with the triangle as it is. Figure out what is it that I need from the triangle that I'm given. That is the condition. So we are going to see another part later on, which is actually the end part of this synchronous motors when they are being connected. We are going to have that one as the last class, but after this, we are going to look into examples. So make sure you work out as much questions as you can, and do not forget to revise when you are dealing with the capacitor bank, just like what we worked here using those trigonometric ratios, Pythagoras theorem, if it is applicable, all those you are supposed to revise them. You are going to need that information to answer these typical questions when the synchronous motor is being installed. So that is it, guys. Till we meet again.